Hello everyone, we are Ver Biotech, a next-generation chemicals company that combines biotechnology and innovative purification strategies to develop more sustainable chemical production platforms. Succinic acid is a valuable chemical due to its ability to be converted into a variety of intermediates and biodegradable polymers across several industries. However, current production relies primarily on petrochemical feedstock, resulting in increased greenhouse gas emissions and environmental damage. Bio-based production has been attempted in the past using corn or wheat glucose and a microorganism catalyst, but the significant price drop of oil in 2014 caused bio-based competitors to drop out due to costly and unreliable feedstocks. Fair Biotech has designed a process that utilizes methanol feedstock and engineered microorganisms to produce 35,000 metric tons of clean, cost-effective succinic acid per year.
For the proof of concept, we evaluated our proposed process using mechanistic simulations in Python and Aspen, as well as flux balance analysis, also called FBA. The performed FBA estimated exactly how much succinic acid and biomass could be produced with a 0.9 molar methanol feedstock in our genetically engineered microbial biocatalyst. We genetically engineered our microbe to overexpress a succinate synthesis pathway known as the glyoxylate shunt to maximize process productivity. After investigating different bioreactor strategies, we settled on a continuous perfusion system that consists of 4 different 2,500-liter reactors running in parallel. Before downstream separations, these reactors can produce over 41 million kilograms per year of succinic acid.
The separations process was modeled in Aspen. The product from the bioprocess first goes through a flash separator, which eliminates most of the unwanted products from the bioprocess. The product stream is then cooled and sent to a crystallizer, along with some cooled water, which then converts the succinic acid into a solid form. Finally, we use a filter which eliminates the majority of the liquid that may be left over. Overall, this process is very effective in generating a large amount of pure succinic acid and is relatively inexpensive, which increases the likelihood of long-term commercial success.
Under a 22-hour operation day for 340 days, the proposed process will generate over 35,000 metric tons of succinic acid annually at a purity greater than 99.9% and with a yield over 96.1%. Major safety concerns for this process involved the operations of methanol and the genetically engineered microorganism. To reduce hazards from methanol, the chemical will be delivered to the plant on a daily schedule to keep the methanol inventory at a minimum. Although the genetically engineered microorganism does not pose a risk to human health, it will be operated in a sterile and isolated environment and will be pH neutralized prior to disposal.
To compete with low-cost petrochemical processes, financial profitability is a key goal for the success of this project. Under our product pricing model, Vert Biotech is expected to achieve $136 million in annual revenues with a 31% gross margin. After considering operating costs and other expenses, $23 million in net income will be generated. The initial investment needed, representing the total ISBL, OSBL, engineering, and contingency costs, was determined to be $35 million. With the assumption of a 15% cost of capital, the project is projected to grow to more than $150 million in enterprise value over the next 15 years. Looking forward, Vert Biotech has many opportunities for continued growth. We may consider using other microorganisms or genetically engineering our own for more efficient production. Additionally, the team may also consider taking the project further downstream to produce bioplastics. By executing on any of these levers of growth, Vert Biotech will continue disrupting the biofuels market.